In this question, it is given that let alpha be a positive real number such that f takes r to r and g takes the interval this to r be the functions defined by this and this. Then the value of limit x tends to alpha plus fgx is. First of all, note an important formula which I am going to use in this question, and that is limit x tends to a. Suppose sx and tx are two functions of x, then we are allowed to write it as s limit x tends to a tx. This is allowed only if at the limit of this, that is if limit of is lambda, if s is continuous at lambda, then only this operation is allowed. That is, limit can go inside provided at the limit of this the function s must be continuous. You must know this formula and I'm going to use it in this question. And because it is clear that fx is always continuous at every value of x, therefore limit x tends to alpha plus f of gx can be written as f of limit x tends to alpha plus gx. And my question now reduces to only finding the value of this. And now limit x tends to alpha plus the value of gx is this, that is 2 into log of unroot x minus unroot alpha upon log of e to power root x minus e to power root alpha. Further, there are so many ways of doing this question, but the best will be with the help of L'Hopital's rule. Limit x tends to alpha plus 2 upon unroot x minus unroot alpha into 1 by 2 root x upon 1 upon e to power root x minus e to power root alpha into e to power root x into 1 by 2 root x. Obviously, this will get cancelled and I get 1 upon e to power root alpha into limit x tends to alpha plus e to power root x minus e to power root alpha upon root x minus root alpha. Note that I have taken the limit of this part and this is e to power root alpha I have taken common. Note that for taking the limit of a part of the question, that is allowed only if that part is in multiplication or division with remaining whole question and limit of that part is non-zero finite also. And because it is satisfying both the conditions, therefore I have taken the limit of this and taken outside. This is equal to 1 by 2 here. If you see carefully, we can use L'Hopital's rule once again. Otherwise, if you see carefully, this is the derivative of e to power root x with respect to root x at x equal to alpha, and therefore the value of this becomes e to power root alpha, that is 2 e to power root alpha into e to power root alpha into limit x tends to alpha plus e to power root x minus root alpha minus 1 upon root x minus root alpha, and the value of this is clearly 1, therefore the answer is 2. That is, this can be proved equal to this in so many other ways also. And because we have got the value of this as 2, means I have to find the value of f2, and using this, f2 is sine pi into 2 by 12, that is 1 by 2.